All right, so I'm recording and we're doing example 20. Oh, I didn't even write it down, but essentially it's telling us to differentiate y is equal to 10 to the 6th power 4x 4x plus 5. Um, well, the way you should view it is the way it is to the right, where it's the same as saying tan 4x tan the tan of 4x plus 5 raised to the 6th power. So here it is both composite, the outer function, when you differentiate in the outer function, that's a power differentiation. And then the inside function is tan. When you differentiate tan, you're going to get sec squared. So I would say dy by dx, differentiate the outer function, so the 6 comes to the front. In bracket, I will still have tan 4x plus 5. The power decreases by 1, so the power becomes 5. Then now I have to differentiate by the differential of the inside function. When you differentiate tan, you're going to get sec squared. And it's sec squared 4x plus 5. Then I have to also multiply by the differential of the inside function, which is 4x. When I 4x plus 5. When I differentiate that, I'm going to get 4. So my final answer should be 4 times 6 is 24. And we have tan to the 5th power 4x plus 5 sec squared 4x plus 5. Any problems with what I did? And as I said, there it is, it's 2 lines.
No, sir. I think my only issue was that I didn't think I needed to put the 4x plus 5 for 6 squared.
You always have to put it back, because that it is tan of that angle. The angle is 4x plus 5. So if you put sec square, it must be sec square of the same angle, 4x plus
Okay.
5.
Yeah. But other than that, I'm fine.
All right. Anybody else? A comment about example 20? Anybody? Renee, are you back? Renee? All right. Renee may be gone to sleep. Chanel, you are there?
Yes, sir.
Very good. Tahira, you are there?
Yes, sir.
Good. Ariana, you're here?
Yes, sir, I'm here.
Good. So the only person we're not hearing speaking any at all is Renee. So Renee, if you have any issues, can you send me a text message? Sorry, can you send me a message in the chat or something? If you have any issues with your mic or something, let me know. All right, guys, let's have a look at example 21. All right, obviously this is a product differentiation. And product differentiation is, the formula is, if y is equal to u v, dy by dx would be equal to u dv by dx plus v du by dx. So sometimes I just simply said, I would just simply say leave the first, differentiate the second, plus leave the second, differentiate the first. So u is this and v is this. So dy by dx would be leave the first, which is cos 3 phi. Differentiate the second, and differentiate tan, you get sec square. So this is sec square 3 phi. But never forget that you must also multiply by the differential of the inside function. I'm sorry, this is not with respect to x, it is with respect to phi. So it's dy by d phi. So dy by d phi. All right. So that is the first thing. Leave the first, differentiate the second, plus leave the second, which is tan, and differentiate the first. The first is cos. When you differentiate cos, you're going to get minus sine. So this is minus sine
Wait,
3
sir.
5.
Excuse me, sir.
Go ahead.
So why do you have sec raised to the third power?
Sorry, that should be sec square. So that's an error.
Okay.
All right. So differentiate cos, you get sine 3 5, and you multiply by the differential of the inside function, which is 3. And of course, you leave the second, which is tan 3 5. And so what we have here is cos, sorry, 3 cos 3 cos 3 5 sec squared 3 5 minus 3 sine 3 5 tan 3 5. Hope we didn't leave out anything. So this is the same, and we want to get it to look like on the right hand side. This is 3 cos 3 5. Now, if the examiner did not say that, you know, if I did not know that this was the expectation, I would have just stopped here. But since I know, let's continue working. Sec is the same, sorry, sec is the same as saying 1 over cos. So this is times 1 over cos square 3 5 minus 3 sine 3 5. Tan is the same as saying sine over cos. So this is sine 3 5 over cos 3 5. Stay with me. So obviously this cos here is going to cancel one of the cos at the bottom. So over here, I just have 3 over cos 3 5. And to the right, I'm going to have minus, and this is 3. Sine 3 5 times sine 3 5 is sine square 3 5. And this is over cos 3 5. Now, if I'm adding fractions and the denominators are the same, I simply just add the numerators. So I have 3 minus 3 sine square 3 5 over cos 3 5. Up the top, 3 is common, so I'll factor out the 3. So I have 3 into 1 minus sine square 3 5 divide by cos 3 5. Now, 1 minus sine square is the same as saying cos square. So this is 3 cos square 3 5 divide by cos 3 5. Cos 3 5 into cos square 3 5 is cos 3 5. And so our final answer is 3 cos 3 5. Our final answer is 3 cos 3 5, which is what the examiner was telling us that we should get. All right, so this is it, down to the final answer.